Hello viewers, welcome to Big Boy Physics, and in today's video we'll be discussing about application of derivatives in the subject physics. Okay, this is the seventh lecture of basic maths, and in today's video I have written in the heading we are discussing about AOD. Okay, before discussing about AOD, probably I gave you a homework problem that is just a minute. Yeah, that is if y is equals to x to the power x, then what is the value of dy by dx? Probably I have given you this problem. Now how to solve this problem? Observe that x to the power x, now it's not of form x to the power n or a to the power x. Okay, it's neither of them. So we need to define something of our own. What I'll do is we'll be taking logarithmic both sides, and it will be natural log. We'll take ln both sides, and we'll get ln y is equal to x into ln x. Okay, from here you will get ln y is equal to x ln x. Now differentiating this both of the sides of the equation with respect to x, you will get 1 by y dy by dx is equals to ln x plus x into 1 by x, which will come out to be 1 plus ln x. From here you will get dy by dx is equals to x to the power x into 1 plus ln x, and that's the answer. Well, the step that is taking the logarithmic both side was the crucial step here. Here you cannot apply chain rule also because it's not a predefined function. You have to define the function on yourself. This is not something which is taught. You have to do something which will be satisfying and will help you to differentiate easily. Okay, so that's why we took this approach by using logarithmic differentiation. Well, you may find logarithmic differentiation useful in the topic of errors. Okay. Errors will be discussing a little later after basic maths. Till then, just focusing on what we are currently in it. Now, talking about application of derivatives. First is to find rate measure. If you are given a relation between the displacement, that is x coordinate of the particle as a function of time, then what will be the velocity? Velocity will be the derivative of x coordinate with respect to time, which means that if you are given x coordinate as a function of time as something like this, then the tangent at some point p is given as the velocity. The slope of the tangent is the velocity of the particle at point p or at time is equals to tp. Okay, so basically the velocity at time is equals to tp will be dx by dt at t is equals to t, right? For example, suppose you have a function of or a relation that the displacement of a particle as a function of time is given as 27t plus 4.9 t square. Okay. Now this may bring you back to your class 9th memories because it's written as g by 9, and this is u. Basically, it's saying that we are throwing a ball. Now u is equal to it's thrown downwards with 27 meter per second, and it's thrown under the influence of gravity. That is the velocity direction and the gravitational acceleration direction are parallel. Okay, so you might get these vibes. Now, if you are asked to find the velocity of particle at time is equals to 3 seconds, what we'll do is just differences ds by dt at t is equals to 3 seconds. We will get 9.8 into 3 plus 27, and if you further evaluate, you will get the answer to be somewhat 56.4 meter per second. Now, if you are asked to find the acceleration is basically the rate of change of velocity with respect to time, which is written as dv by dt. You will get it to be 9.8 meter per second square. Okay, I hope it's clear. Till now, I have not discussed much of this. This is just enough for knowing about this derivatives. Just you need to know about dv by dt is equals to acceleration and dx by dt is equals to velocity. Now the second application is maximum and minimum. Now before that, I'd like you to ask you something. Yesterday, I discussed about d2y by dx2. as the second derivative. Now what does this mean? This basically represents the rate of change of slope, right? Suppose you have a curve somewhat like this. If as x progresses, you can observe that the slope changes. Hence, the slope actually gradually increases as x progresses. Thus, we say that d2y by dx2 is greater than 0. Now, for this curve we observe that this slope is this curvature is actually pointing towards the positive y-axis, right? If you take any normal, then it points towards the positive y-axis. That is what important about this d2y by dx2. इफ यू अगर तुम्हें छाते के बारे में पता है तो छाता क्या होता है, कुछ ऐसा इस तरह का दिखता है। अब देखो छाता का जो हैंडल है उसे तुम एक एरो मानो और जो छाता है उसका सरफेस को एक कर्व मानो। अब देखो कि जो छाता है उसका जो मुंह है वो नीचे की तरफ झुका हुआ है और जो उसका डंडा है वो भी नीचे की तरफ पॉइंट कर रहा है। अब हमें पता है कि नीचे की तरफ पॉइंट करना मतलब कि ये नेगेटिव है, बिकॉज वी आर पॉइंटिंग डाउनवर्ड डायरेक्शन। सो इन दिस केस ऑफ कर्व लाइक दिस टाइप, I am shading with a red color rather. For the curve like this, we say that d2y by dx2 is less than 0. And similarly, if we have a curve like this, इसका छाते का हैंडल ऊपर की तरफ पॉइंट कर रहा है तो उसमें कहते हैं d2y by dx2 is greater than 0. I basically mean to say that if you have an umbrella and you open it, you will get a shape somewhat like this. I'm setting it. You'll get a shape somewhat like this. Now the curve shape is like just a parabola. Suppose it's a parabola. Then the umbrella's handle is pointing in the downward direction. This implies that if the curve is somewhat like this, it bulges towards the upward direction, then you can say that d2y by dx2 is less than 0 for this curve. And if it's just like an umbrella which is pulled vertically downwards, then it's d2y by dx2 greater than 0. Now two conclusion I can found that if we as x progresses, as the x coordinate progresses, here there will be a certain point at which maxima will be obtained. Since maxima is getting obtained, this means that at the point of maxima, dy by dx is equals to 0, and for maxima to exist, d2y by dx2 should be less than 0 at that point P. Suppose the point is P. So at that point P, the derivative should be 0 and d2y by dx2 should be less than 0 at point P. Now you may come across few examples in which the d2y by dx2 and t also tends 0 as dy by dx tends 0. Okay, so we are not taking about those examples currently in this session. You'll read about them in mathematics class 12. Okay, so not to worry about it. Our first ever example, y is equals to ax square plus bx plus c. Now we need to find the point at which the maximum or the minimum, whatever it comes. Then you have to put is that dy by dx is 0. From here you will get the x coordinate to be minus b by 2a. So at x equals to minus b by 2a, the curve attains the extreme values. I can't say whether it's minimum or maximum. Now what is d2y by dx2? d2y by dx2 is actually a 2a, and if 2a is greater than 0, this implies that the curve will have minimum, and if 2a is less than 0, then it implies that the curve has a maximum. So that's it for minimum and maximum. We do not have to worry much about them. Now we'll be getting two examples of maximum and minimum, that is local maximum, global maximum, and local minimum, global minimum. Okay, so I'm not talking about local maximum, local minimum, maximum, and global minimum. I'm taking some more questions for strengthening your concepts. Well, if you want to look about the global maximum, global minimum, and local all those, then you can refer to any mathematics playlist. You can look at it. You can understand about global maximum and local maximum, all those stuff. Okay. So taking a question that you have x is equals to 5t square minus 90 plus 3 x as a function of time. Then can you tell me the maximum coordinate of the particle? What will be the maximum possible coordinate of particle? As I just said, that 2a greater than 0 implies minimum. Since 2a is 10, so it should be greater than 0. So this curve will basically have minimum rather than having maximum. So even if they tell you to find the minimum, so the x is minimum when time is equals to 9 by 10 seconds. Right? Hope you get it. Taking another question. Now this question is a very famous question. You might know about it. F of x is equals to x plus 1 by x. Then for all x greater than 0, what is the minimum value? This is the standard AMGM question which you will encounter in class 11 mathematics itself. Okay. So to do this, we can also involve some a bit of calculus. That is just differentiate. You'll get 1 minus 1 by x square. From here, we'll get x equals to 1. We'll have extreme values. We are not taking x equals to minus 1 because we are already restricted that x is greater than 0. So x equals to 1 gives us a possible extremum value. Talking about the double derivative, we'll get 2 by x cube, positive sign, and putting x is equals to 1, you will get it to be 2, which is greater than 0. This implies that since f double dash x is greater than 0 and f dash x is 0 at x equal to 1, this implies that x equal to 1 is the point at which f of x attains the minimum value, and the minimum value is equals to 2. I hope you get it. And so this was about this differentiation. Now another application of differentiation I am going to show you is radius of curvature. This is the last topic I am taking of differentiation. Now this is a little challenging one, I'd rather say, an interesting one. Suppose my curve is somewhat like this. I don't know my curve. I take a segment. I need to find the radius of curvature x equals to x naught, or suppose at x equals to x. Okay. Now I take a belonging point x equals to x plus dx. Consider two close packed normals, and suppose they intersect at some point O. Now O distance from this curve is basically the radius of curvature. So suppose this angle, the tangent or to the first point x makes an angle theta, and the second one makes an angle theta plus d theta. So I can say that this angle is equal to d theta. And what will be the length of the curve? Length of the curve is ds is equals to dx whole square plus dy whole square is equals to r d theta. Now dy by dx is tan theta. I hope you know this. Dy by dx is tan theta. Just basic definition of derivatives. Now differentiating it with respect to x, you will get d2y by dx2 is equals to sec square theta d theta by dx. So I can say d theta is equals to d2y by dx2 whole into dx, and sec square theta can be written as under 1 by tan square is equals to tan square theta plus 1. So I can write it as dy by dx whole square plus 1. Now multiplying with radius, you will get it to be under root dx whole square plus dy whole square. Okay. From now further simplification, you will get it to be 1 plus dy by dx whole to the power 3 by 2 upon d2y by dx2 is the formula for the radius of curvature of the given curve at a general point. Okay. Now suppose a circle. I am taking a standard circle. Then using parametric differentiation, I will be using parametric differentiation here. I will put x equals to a cos theta, y equals to a sin theta. Yeah, here is another whole square term. I probably missed it out, right? So now for a circle, x equals to a cos theta, y is equals to a sin theta. Then we know that a is a constant. and it's a positive real number. Hence, dy by dx can be written as dy by d theta upon dx by d theta, which will get minus a sin theta minus a cos theta by sin theta. Hence, it would be cot theta, right? So dy by dx is equal to minus cot theta. Pardon. Now, what will be d2y by dx2? d2y by dx2 will come out to be cosec square theta d theta by dx. To find d theta by dx, just differentiate this equation. You'll get 1 is equals to a minus sin theta d theta by dx, right? So I can say d theta by dx is minus 1 by a sin theta minus 1 by a sin theta into cosec square theta, right? So now just further simplification will yield you cosec cube theta upon a with a negative sign, and hence now dy by dx whole square plus 1 is equals to cosec square theta. Now taking whole to the power 3 by 2, you will get cosec cube theta. So the radius of curvature is equals to division by d2y by dx2. You will get it to be minus cosec cube theta into a, which will come out to be minus a. Now we are generally interested in the sign in the magnitude rather than sign. So we keep a mod in the outer portion. Okay, the whole expression is taken inside the mod. So we'll take the mod. We'll get the radius to be a. This is the general formula for radius, and hope you enjoyed this video. That's it for derivatives, and in the next video we'll be starting with integrals. So that's it for today. Thank you. Have a nice day.